This pedigree shows the incidence of opalescent dentin in a family. To solve the mode of inheritance, let's first of all write down the possible modes of inheritance. AR is autosomal recessive, then we have X-linked recessive, autosomal dominant, X-linked dominant, and Y-linked. First of all, it's not Y-linked because females have the trait. Y-linked traits are only in males, therefore, this one is not Y-linked. So we're going to cross out the possibility that it is Y-linked and give the reason that Y-linked traits are only in males. Next, we see two parents that have the trait and their child does not have the trait. Let's look at this here. If two parents have a trait, let's say this trait was recessive, then both parents would have to have the recessive genotype and all their children would have to be affected by that trait. Because couple 2-3 and 2-4 has a child without the trait, this trait is not recessive. So let's cross out the two possible modes of recessive inheritance. And the reason is that two affected parents have all affected children. Next, let's look to eliminate XD. And let's look at how we do that. So if a male has an X-linked dominant trait, he only has one X chromosome, which he has to give to all of his daughters. And because this daughter is not affected by this trait, so she did not inherit the X capital A, that means that if any male with the dominant trait had a daughter without it, then it's not XD. It can't be, because how did she not inherit that X from him? So that's what we're looking for on the pedigree. A male who has the trait and his daughter does not. And it's right here. Therefore, this pedigree is not X-linked dominant. So we're going to cross out that mode of inheritance and give the reason that affected males have all affected daughters. So we have found that the mode of inheritance for this pedigree is autosomal dominant. And we can give the reason that it does not skip generations. To make sure that's true, you can check from the bottom of the pedigree up. Any child with the trait has to have at least one parent with the trait. Let's write the legend for this. Because we said it is autosomal dominant, we're not going to use any X's in our legend. We're going to use capital A to represent the affected individuals because it's dominant, and lowercase a to represent the unaffected individuals. Next, we will apply this to the pedigree. I like to start with all the recessives because we know their genotypes for sure. Everyone who is not shaded in is going to have the recessive genotype. After we've labeled all the recessives, we can then label the dominant people, the ones that are shaded in, with at least a capital A, and then we check, does one of their children or one of their parents have the recessive genotype? And if so, their other allele must also be recessive. And that is true of everyone on this pedigree. All of them have either a child who is recessive or a parent who is recessive. So to answer number 3, the mode of inheritance is autosomal dominant. Let's take a look at numeric response number 2. If individual 3-6 and individual 3-7 had another child, let's look at them. Here they are, 3-6 and 3-7, and their genotypes are big A, little a, and 2 little a. So we have one heterozygous individual, and the other individual is recessive. Let's put that into a Punnett square to find the probability that this child would be male with opalescent dentin. So remember, we write the possible gametes from one parent on the one side of the Punnett square, and the other parent along the other side, and then bring them back together. And we find that 2 of these have a chance of having opalescent densin. So that's 2 out of 4, or 1/2, or in other words, 0.5. Now we need to multiply that chance by the chance of having a son or a boy, which is also 0.5. So our final answer then is 0.25, and we are to write it as a whole number percent. So that is 25%.